This video is over chapter 36, the root test. So first of all, I want to review the root test. So again, we have a series that we've made from the sequence of partial sums of a sequence. And now to apply the root test, we'll take the limit as n goes to infinity of the nth root of the absolute value of the nth term. The conclusions are similar to that of the ratio test. If our limit is L, which is less than 1, our series is absolutely convergent. If our limit is L, which is greater than 1, or it's infinity, then the series is divergent. If the limit is actually equal to 1, then our test is inconclusive. And like the ratio test, you will see that there's no conditional convergence here. Things are not conditionally convergent by the root test. If you apply the root test, the series will either be absolutely convergent, divergent, or the test will be inconclusive. So I'm going to do example 223, which is in your notes, and I am also going to do an added example from this chapter that's not in your notes. Using the root test, so how do we know when to use the root test? Well, one good indicator is the fact that we have an nth power here. And so when we take the nth root, then this power disappears. And so to apply the root test, we will take the limit as n goes to infinity. So we'll take the absolute value of the terms calculate the absolute value, then we take the nth root. This simplifies nicely. We simply have n plus 1 divided by n squared. The absolute value of negative 1 to the n is simply 1. And this limit is 0. And so 0 is less than 1. So our conclusion is that our series is absolutely convergent by the root test. Now, this series, we have something to the n squared and not just the n. This is still a good indication that we want to use the root test. So, before we apply the root test, I want to remind you of something. That the limit as n goes to infinity of n plus 1 over n to the nth power, more commonly written like this, is Euler's number. Because of that, the limit as n goes to infinity of the reciprocal n over n plus 1 to the n is the reciprocal of Euler's number. So we want to keep this in mind as we apply the root test. So applying the root test to this example means that we are going to calculate the limit as n goes to infinity of the nth root of this term. And we will calculate the nth root. I left out the absolute value here because these terms are always positive. Now, let's rewrite this. When we take the nth root, that is the same as the 1 over n power. Then from our properties of exponents, we can write this as n divided by n plus 1 to the nth power. This is 1 over e, which is strictly less than 1. And so this series is absolutely convergent by the root test. Absolutely convergent is a little redundant here because these terms were already positive. So for this example, convergent and absolutely convergent mean the same thing. So this concludes the video of the root test.